get going. So what we're looking at today doesn't look like a lot, but it actually is. We're going to cover geometry for the first half of class, take a short break, and then come back and look at reading comp. And like I said, reading comp, we're going to be using one of the handouts especially. One of the handouts that I sent you guys has the reading comp passage on it, or the first one that we're going to look at. So that's pretty important. Okay, any overarching questions that you guys might have before we dive right in? How's the studying going so far? Are you guys feeling like you're making improvements? Good to see. Good to see. I'm glad to hear that. We're now, about halfway through the course. Actually, the midpoint of today's lesson is the halfway point of the course. So hopefully you guys are starting to see that the hard work you're putting in is paying off. And yeah, totally understand falling behind here and there. And that's okay. There'll be a little bit of time after the course ends for you to wrap everything up and get all caught up and finish all of the studying that you need to do. But just try to make sure that every week, even if you know you're going to fall a little bit behind, you try to get through some good portion of it, maybe a third of it or a half of it at the bare minimum, just to keep your momentum going. Sometimes people take breaks and come back to it after not studying for a while, and they're really in a lot of cases starting over from scratch or nearly from scratch. So you don't have to constantly be putting in 25, 30 hours a week of homework. You can have lighter weeks, but you want to at least do a little bit and just keep things moving on. That's a great question, Caitlin. A lot of it depends on how much work you actually are getting done with in class. But I would say at a minimum, give yourself 2 weeks after the course ends to wrap up your studying and get in a good frame of mind for taking the test. If you're way behind, then after that 2 weeks, you're still going to need more time to get finished with all the work that you missed originally. I wouldn't, though, push it any further back than about 2 to 3 months, just simply because if you push it back too far, it's easy to kind of let things slide, and then all of a sudden you haven't done enough work for a couple of weeks, and you're really losing ground instead of gaining ground. But somewhere in that 2 week to 2 month range, depending on how much work you were able to accomplish during the 9 weeks, or I guess with the break we had for July 4th, the 10 weeks of the course, is important to judge. And yeah, as Liz is saying, man, it is a lot easier to make yourself study if you know that there's a date that you're taking the test on. Even if that date's somewhat in the future, having a deadline really can help you get your focus in. So good question. We'll talk more about things like that over the final couple of weeks as well. But yeah, you definitely want to have a plan in place and have a pretty good idea of when you're taking it, so you know how to spread out your studying. So geometry is the first subject that we're going to touch on today. Geometry. I love geometry. I think geometry is always a lot of fun personally. What's great about geometry is that nothing is just, what's the right word I'm saying? Nothing is just true because some mathematician defined it as true. Basically, all of geometry can be derived from a couple of really simple principles in just definitional stuff, like what is a line, what is a point, what is an angle, how many degrees are in a circle, how many degrees are in a triangle. Once you've got those basics down, you can actually derive, by that I mean figure out for yourself, almost every formula in geometry. Now, on the day of the test, I don't want you guys having to do that, obviously. It's better if you just have learned them perfectly and have them memorized. But it is kind of a cool feature about geometry is that it really is kind of a hands-on sort of math that you're really able to understand exactly why it works, which I think is pretty neat. That being said, this is probably the field of math that you guys have done the least of since high school. In other words, in day-to-day life, you probably do a lot of fractions, decimals, percent stuff. In day-to-day life, you might even do some basic algebra. Even if you don't call it that, when you're trying to figure things out, you might be using algebraic techniques. A lot of arithmetic stuff you're doing day-to-day, but geometry, people probably, for the most part, don't do a lot of it in their everyday life. There's very little call in most people's careers for figuring out, let's say, the area of a circle, or figuring out the third angle of a triangle or something along those lines. So geometry, I think, for most of us, is probably the topic that we've forgotten the most about since we studied it in 9th grade or 10th grade or 8th grade or whenever you might have studied it. So let's talk about some basic principles when we're dealing with geometry. So the first basic principle is, if they don't tell you something, do not assume that you know it's true. So for instance, over here I've got a circle, and inside that circle I've got inscribed a triangle. And boy, that looks like a right triangle, doesn't it? That angle right at point B looks like it's a right angle. But until the GRE tells me that that's a right angle, or gives me some way to infer it, I can't assume it. And in fact, this is really, really important with right angles, because there's a lot of things that we're able to do with a triangle if we know that that triangle happens to be a right triangle. And those sorts of things that we can do when it's a right triangle, mostly revolving around the Pythagorean theorem, those are things we absolutely cannot do. Absolutely cannot do if it's not a right triangle. So sometimes the test will give us stuff that looks like a right angle, and hope that we misinterpret that, and hope that we assume it's a right triangle, and then go ahead and use formulas or approaches that are not relevant in that case. And of course, they do that with all sorts of different shapes, but this is, in particular, the right angle thing is one that happens a lot. But on the other hand, if they do happen to give us a piece of information, we want to be able to use it. We want to be able to use it directly, and we also want to be able to infer from it any additional information that we might be able to figure out. A lot of geometry is taking the given statements and using them to help you, based on your knowledge of the different shapes, your knowledge of the formulas, use them to help you figure out additional pieces of information. So I'll toss this open to the class. Any ideas here? What do we know if AC is the diameter of the circle? It's not just a random line in the circle, it's the diameter. All right, Catherine, how do you know it's a right triangle? Hop on the mic. Okay, no worries. You can type it for us. How do we know it's a right triangle, given that this is a diameter? Okay, there you go. That's fine. I mean, that works just as well, and I agree with you 100%. This is definitely a right triangle. Does anybody know why? Ooh, okay. So long term. So let's stick with the principles, and I'll show you guys why in a second. But Catherine is exactly right. This is going to be a right triangle, and it's going to be a right triangle at the angle opposite the diameter. And so we want to be able to infer this, but inferring this basically requires us to know our rules and formulas. And the rule here is that a triangle inscribed in a circle is a right triangle if one of the three sides is the diameter of the circle, or a diameter, I should say. And that's just a rule that is worth knowing. Now, here's what I want to do, because I want to show you guys how fun geometry can be. And if this doesn't work, then I'll give up on geometry being fun. But this is not actually the whole rule. In fact, this is a subset of a much bigger rule that has to do with circles and angles. And I want to show you guys exactly how that works and how we can derive that a right triangle that a triangle in a circle with one side the diameter is a right triangle. So let's draw a new circle here. All right, so I've got a circle, and I'm going to make a point in the center of that circle, and I'm going to create a diameter. So pretend for a second this is the diameter of the circle, and pretend for a second that this is the center of the circle. And I'll try to hit this as closely as possible, but you guys will forgive me if my picture is not perfect. Okay, so I've drawn one more line. So from the center of the circle to the edge of the circle, what do we call those three lines? One of them is two of them put together making a diameter, but what do we call the individual lines there? Okay, so each of these is a radius. What is true about every radius in a single circle? All right, they're all equal. It's the same no matter where I put it. So this R is identical to this R is identical to this R, and Jignacia is exactly right. It's half of the diameter. Okay, I'm going to give you guys one more piece of information here. I'm going to tell you that this radius meeting this diameter is a right angle. Okay? So one final line, and I hope that we'll start to see what's going on. One final line. I want you guys to tell me, what is the measure of angle X? What is the measure of angle X? How many degrees is X? Emma, any idea how it's 45? Yeah, it's an isosceles right triangle because we know that these two radii are identical. Therefore, their opposite angles are identical as well. So this is 45 degrees. Okay, last part, and then we'll know exactly what's going on with the previous slide. How many degrees is this portion of the circle? How many degrees is this? If this is a 90-degree angle right here, this is 90 degrees of arc. We could call it 1/4 of the circumference, and we'll come back to that idea later, but we can also call it 90 degrees of arc. So here's the rule. When two lines in a circle, and we're going to call them, anybody know the special name for a line in a circle that goes from one point on the circle to the other, not necessarily through the middle? In other words, if I just draw this red line right here, what do we call that line? Anybody know? Think about the name of a Honda. It's a Honda what? Yeah, except they spell it CH. All right, so that's a chord. The diameter is just a chord. That's all it is. It just happens to be the special chord that goes through the middle. So anytime two chords meet at a point on a circle, their angle measurement is half of the arc they enclose. So if this is 90 over here, this is half of it. And the cool thing about it is I've drawn it using the picture I originally used because that makes it easier for you guys to see why that's working. But it actually works no matter how I draw that chord. So let's say I drew it like this. I went from here to here. If this is 90 degrees all the way around this arc, and that's 90 degrees, what's this angle have to be? It's still going to be 45 degrees, even though I've drawn it in kind of a weirder way. Okay, we now know enough to understand the special rule on the previous slide. From A to C is how many degrees? Anybody know? How many degrees is that? If AC is the diameter, then how many degrees of arc is this? It's 180 degrees of arc because it's exactly half the circle. So if this is 180 degrees of arc, then this angle right here has to be half of 180 degrees, which means it has to be, as Jignash is telling us, 90 degrees. So the broader rule is that if you've got two chords meeting at a point on a circle, their angle measurement is half of the enclosed arc. The special rule is that implies that a triangle with a diameter as one of its three sides inscribed in a circle must be a 90-degree angle because it's opposite that 180 degrees of arc. Very cool, right? So the point I wanted to make is that now I'm hoping you guys are going to remember this rule better, because now you know where that rule is coming from. It's a special version of a more general rule. And if you know the more general rule, you can derive stuff like this from it. Now, this is actually really advanced geometry stuff we just did, and you guys handled it without a problem. But this is really high-level geometry stuff. But it does occasionally show up on the test. It's worth knowing. Questions at all about this? All right, let's keep moving then. So we've seen the principles, right? Don't assume, use everything they tell you, and infer based on what they tell you additional information when possible. So let's see the process, the actual what we should be doing as we're working these problems. Number one is to take on your scratch paper, take your scratch paper and redraw the diagram that they give you. And if they don't give you a diagram, if it's a word problem but it's geometry, draw it from scratch. And then add in all of the information you need to know, all the information they've told you especially. Don't leave anything out. One of the problems people have with geometry is they'll sometimes tell you 3 or 4 different givens in a problem, and sometimes we don't know exactly how to use one of those givens, and so we ignore it. Well, if we get stuck, that's where the problem is. They're never going to give you on the math side information that's completely useless. Everything they tell you, for the most part, is going to be required to solve the problem. So we want to make sure we've added in everything that they've told us, even if that just means rewriting it below the diagram until we know exactly how to use it. Number 2, make sure you know exactly what they're asking for. I can't tell you how many times this has happened to me, where I'll get a complicated problem that maybe has 4 or 5 different unknown angles, and you're able to figure out all the angles, and it turns out that the one they want is the third one you figure out, and you keep wasting time finding the 4th and the 5th angle beyond that. I've done that a ton of times. If things are less bad, then when I go back to the answers, I realize I've made that mistake. When things are really bad, I pick an answer that corresponds to the angle I got to, not the angle they were asking about. So make sure you put in big, bold, like draw an arrow to it or circle it, the thing that they want, right? Maybe even make up a variable for the wanted element. Maybe call it X and put down right there on your paper, X equals question mark, to remind yourself what your end goal is. And finally, and we said it on the previous one as well, but infer from all of the givens. Take all the information they've given you and use that to fill more and more information into your diagram until you've got everything that you can figured out. And create and solve equations. Oftentimes geometry is not really about geometry. Oftentimes geometry is actually a way for them to test you on algebra without setting the problems up in the same way. So in other words, instead of just giving you a word problem or giving you, an equation or an inequality, sometimes they can give you a picture, but still the core math that you're going to be doing to solve the problem is algebra once again. In fact, a lot of geometry problems end up being more algebra than geometry. So never be afraid to create and solve equations. Here's a really simple one. What if I've got a triangle and I've got 3 variables for the angles? What's an equation I could create with all 3 of those variables? Just a real simple equation that would let me put all 3 of those variables together. Yeah, absolutely. I can I can just create an equation that says A plus B plus C equals 180, the sum of the angles. Now, why might that be helpful? Well, maybe later on in the problem, I'm going to figure out that A plus B is 140. Now I know C is 40, right? So I'm willing to write down some simple formulas that express the relationships between the, simple equations that express the relationships between the different parts of the problem. Even if I'm writing a whole bunch of variables, just getting it down on paper, maybe that's going to help me recognize what I need to do later on in the problem to solve for those variables. All right, questions at all? Okay, let's try a problem out. It's a QC problem, and I want you guys to really think about this before you dive right in. Really think about it. So here you go. I'm going to give you a minute and a half on the clock, and switch the polling over to A, B, C, D here in a sec, and we'll see how this problem goes. Good luck. Okay, I've only got a couple of answers in, so keep pumping those answers in, guys. So here's my question. How should I even begin? How can I use the additional information they gave me? What should I do? What new information have they given me? So O is the center of the circle, okay, and I appear to have a triangle inscribed, okay. The radius is 4. Okay, I'll go ahead and write that down. There's a 4, there's a 4 as well. Oop, that's a really bad 4. That's a really bad 4. So let me rewrite that 4 so we can actually read it. Big and precise, of course, is always helpful and easier to see. Okay, so Emma's telling us it's an isosceles triangle. I agree with that completely. The two quantities, let's take a glance at them. One quantity is just a number, 8. Okay, that's an interesting number. The other is the area of the triangle. So you guys tell me, how do I find the area of the triangle? All right, it's going to be 1/2 the base times the height. Okay, somebody define for me the height of a triangle. What do I mean by the height of a triangle? What's the height of a triangle? Okay, that's half of it. Yeah, the line at which there is a 90-degree angle. That's a good way to put it. Basically, the height of a triangle is the perpendicular distance between one side of a triangle and its opposite vertex. So in this triangle in red that I've drawn below, this would give me the base, this whole line from here to here, and this would be the height of the triangle. The perpendicular distance from the base of the triangle to its opposite vertex. Okay, nice and easy. The problem here is, if you look at this triangle, do we know the distance from P to S? Do we know that base? Because I think all of us are kind of wanting to draw a height like this. Right? Everybody wants to do that, I'm guessing, to make a height. But do we know how big PS is? No, and we're really not going to figure it out ever unless we're given the angles. We're not going to figure that out, unfortunately. So where could I draw the height that would make this problem a little bit easier? And Emma, that's interesting. We can infer the range. But the problem there is even if we infer the range of P to S, we're going to also have a problem trying to figure out the height. Also going to have a problem figuring out the height. But we'll come back to that idea in a second because that's actually a really interesting idea. The thing about any of these is that in any triangle, there's actually 3 different pairs of a base and a height. So sometimes that actually falls outside of the triangle. In other words, if I want to use 4 as the base, I can drop this as my height, as long as it forms a perpendicular angle with where that base would have been. Does that make sense to everybody, that I'm able to do that? Just like in this particular triangle right here, I could have drawn another height that looks something like, let's say, this, or another one that looks something like that, right? In this case, because I've got an obtuse angle, it's actually falling outside. Okay, so let me ask you guys this. If I drew that height like that, that means the base is 4. Now, I still don't know what that height is. I still don't know what that height is. But that height, is that more or less than the radius? Ought to be less than the radius, so less than 4. 1/2 times 4 times less than 4 has to be less than 8, right? Everybody agree? So does that mean the answer is B? Emma and Catherine did not pick B. They picked D as in delta. What's going on here? Seems like I just proved to you guys that the answer should be B. Do we have any disagreement on that? All right, so here's the problem. Do we know that this picture is drawn exactly to scale? We actually don't. We don't know that it's drawn exactly to scale. We can't trust the picture. Now, there are things we can trust about the picture. I can trust O is a circle. They told me that. I can trust that O is the center of the circle. I can even trust that P and S form points lying on the circle, and thus this triangle is inside of the circle. It's inscribed in the circle. But the parts can move around, and Emma's got it perfectly. We can make this a right triangle. And if we make it a right triangle, what's the base and the height? What's the base and the height? Because in a right triangle, they're already perpendicular. So in a right triangle, it's very easy to figure out the area because we don't have to draw a separate line for the height like we did over here, right? Here we can just call one of the 4's the height and the other 4 the base. 1/2 4 times 4, that's going to give us 8. So at its max, we're going to have 8 be the area at its max. If I move either direction off of that, if I'm over here, it has to be less than 8. If I move the other direction, if I move P closer to S, I would also be getting farther away from its max. That right triangle is the max it can be. So since the right triangle, since the max equals 8, what does the answer have to be? Jignasha, is it equal in all cases or just in one special case? That's the real key question. They are equal in one case, and that's this case right here where it's a right angle. But in this case, they're not equal. A is smaller than B. So the answer in the end has to be D, because in some cases they're equal, but in some cases they are unequal. And so that's D. All right, I've got one final question for you. I want to do something very interesting here. Let's pretend that quantity B was an 8. Let's say it's 8.1. What's the answer now? Why is it B, Catherine? Yeah, so the point is, even though we don't know the area of this, we can figure out its theoretical maximum. If its theoretical maximum is less than quantity B, then quantity B is always bigger, even if we don't know it. So the point here is when you get a problem like this, we actually sort of have to figure some stuff out. Because if quantity B wasn't 8, if it was 8.1 or 9 or something, then the answer would have actually been B. But once we realize that 8 is equal to the max, then we know that in one case they're equal and in all other cases they're unequal. Therefore, the final answer to this problem is answer choice D. So what we just got there was a lot of fun with geometry, but we also saw a pretty important issue that arises sometimes with quantitative comparisons. And let me generalize to other types of problems. Sometimes you're going to get a hard and fast number for one quantity, and the other quantity will be variable. That doesn't necessarily mean the answer is D, because it's possible that even though the other side can vary, it's still always smaller or always bigger than the numerical quantity. So we actually can't just say, oh, this one's variable and this one's a number. We actually have to figure out what that variable side can do. Could it be bigger or smaller or equal to the numerical quantity? And if it can be 2 or more of those, then the answer is D. But if it's always smaller or always bigger, then the answer is A or B. So cool lesson both for geometry and a cool lesson for QuantCom in all topics. Questions at all? All right, final point to make here. We call this rubber band geometry because the idea is that they're not going to necessarily draw the pictures to scale. They often won't. And we have to basically be able to recognize what we do know given a picture versus what is variable. What we do know is, yes, P and S are on the circle, O is in the center, this is a triangle, this is a circle, all that stuff. But the exact lengths of things, for instance, we know because they told us that the radii are 4, we don't actually know the length of PS, and that can change as we move things around. All of that is, knowing what we can know and knowing what maybe can move around. And the reason why we call it rubber band is because what's able to change is things that can be stretched, things that can be rotated, things that can be moved. Stretched especially, that's the stuff that can change. The core idea of the order things are in and what the shape is they can't trick us with that. In other words, they can't give us this picture and say, oh, the answer is D because it might actually be a pentagon. No, it's a triangle and a circle, but where exactly P and S are, we don't know that for sure. And that's something that comes up a lot on this test. Questions at all? All right, let's keep going and talk about triangles. Silly question, but is this a legal triangle? And by legal, I don't mean has it obeyed all the laws. I don't mean is it not a criminal. I mean, is it a legal triangle in the sense that could you actually physically construct this triangle if you wanted to? Getting some no's. Getting some no's from you guys. Why not? Why couldn't I take a 2-inch long string and a 7-inch long string and a 9-inch long string and make a triangle out of those strings? Or let's say straws in order to make it so they don't bend. Why couldn't I do that? Okay, that's the rule, that's the formula. Tell me in just natural language, why doesn't this triangle work? And then we'll come back to the rule. What Think about this. If I just took a stick 2 inches long and a stick 7 inches long and laid them next to each other, what would happen? Could I then make another stick that's 9 inches long meet the points at the end of the 2 and the end of the 7? Could I do that? I actually couldn't. And the reason why is 9 is too long. 9 is too long. If I want there to be any angles, 9, this end, if I make this 9, these two ends are too far apart for 2 and 7 to reach. Now technically I could make 2 and 7 work if I laid them on top of each other, right? 2 plus 7 does equal 9. But that wouldn't be a triangle. That would just be 3 lines on top of each other, right? So the rule is any side of the triangle must be less than the sum of the other two sides. So for instance, let's say I got rid of this side and I called it x. What's the biggest x could be? In order to make those meet, in order to make the 2 and the 7 meet, what's the biggest x could be? So this is not a right triangle, Jignatia, so we shouldn't be doing anything in terms of the Pythagorean theorem, which is, I'm assuming, where you got that. And Emma's actually got the answer. It's got to be less than 9. Does it have to be 8? Does it have to be 8? What do you guys think? Does less than 9 mean 8? No, it could be 7, but does it have to be 8 or less, I should say? Could it be bigger than 8? Could it be bigger than 8? And Catherine's totally correct in answering the next question. I could redraw this triangle to make it a little bit more obvious, but basically it's also got to be bigger than 5 because 2 plus x has to be bigger than 7. And the only point I'm making here is it doesn't have to be an integer. X could be 8.9. 8.9 would be a really weird triangle. If it was 8.9, this angle right here would be close to 180 degrees. It would be a really big angle, but it would still be a triangle. So x here has to be bigger than 5 so that the third side is plus 2 is bigger than 7. And it's got to be smaller than 9 because the third side has to be less than 2 plus 7. So you guys should be able to do this with any new triangle. Figure out the minimum for the side and the maximum. And we don't want to think about Pythagorean theorem stuff, square roots, things like that, until we know it's a right triangle. And in this case, we don't know it's a right triangle. All right, questions at all? You guys ready to try this out on some problems? Okay, here we go. Good luck. I'm going to give you guys, for these two problems, 2.5 minutes. Well, let's go 3 minutes because the second problem's a little bit longer. 3 minutes on these problems. Good luck. And when you're finished with both problems, give me an A, B, or C. Oh, no, you can select multiple lengths. So just give me a check mark, actually. Let's do it that way. Give me a check mark when you're done with both. Okay, talk to me. I'll even draw you guys a triangle while you're talking. Somebody get on the mic. Caitlin, what did you do about the first problem? Hop on the mic. Oh, no problem. Jignatia, how about the first problem here? Tell me how to draw it. Okay, well, I'll draw a triangle then. as you're telling me how to solve it. That's totally fine, but I'll draw a triangle so everybody else can follow along. And really, it doesn't really matter how I draw it, so I'll just draw a pretty random triangle. And Jignasha, keep telling me how to do this problem. So AB should be greater than, less than, okay. So let's call this X for a second, and you're saying X should be less than 15 then. 9 plus 6, I agree. What should X be greater than? Because 9 minus 6 is 3, so it's got to be bigger than 3. So we've got, let me redraw this, we've got X has to be less than 15, but it's got to be bigger than 3. Now 3.00000001 would work, right? But 3 doesn't. Okay, so keep going, Jignasha, but we'll eliminate 3. What'd you do with the rest, the other two? All right, both are correct. Now, I agree with you about 13.5. It's less than 15 but greater than 3. What do you guys think about 9 root 3? Let's actually work it out. How big is 9 root 3? Now on the day of the test, this is something you might want to use a calculator for, but you can't exactly do a calculator with this very easily, at least the first step. So what we need to know is, what does root 3 equal? And what is root 2, by the way, because that comes up an awful lot. All right, root 3 is roughly equal to 1.7. It's actually a little bit bigger than 1.7. What's root 2 roughly equal to? 1.4. Yeah, it's a little bit bigger than 1.4. 1.4 is good enough, though. And the way that Liz always remembers this is root 2 equals 1.4. That's so 214. That's Valentine's Day. Root 3 is roughly 1.7. That's 317. That's St. Patrick's Day, which is something cool Liz taught me a couple of months ago that I like a lot. Now I use those because I remember the values. I use the values to remind me what I need to get my wife a present for Valentine's Day, as opposed to using Valentine's Day to help me remember the numbers. But if you remember Valentine's Day and St. Patrick's Day better than I do, you can do it in reverse and use that to remember what root 2 and root 3 are roughly equivalent to. All right, what's 1.7 times 9? Here's where you'd be able to use your calculator very quickly. Yeah, it's bigger than 15, so this one doesn't work. And so the correct answer is only 13.5. 100% absolutely, I want you today to memorize root 3 and root 2. It shows up in geometry all the time, and you'll see that especially showing up a lot with problems dealing with the Pythagorean theorem. Okay, wonderful. Good work. Jignasha did it perfectly until we got to the last step, and that was just forgetting what root 3 is, which will never happen again. But the core idea here is perfect, how we get that X is between 3 and 15. Okay, second problem. I'll toss up the polling. Anybody want to poll in with what you guys got for the second problem? All right. Catherine, or Caitlin. We haven't heard from Caitlin in a while. Caitlin, why don't you tell me how to do this problem?
Well, first, because we know x equals 35, we can put the 35 down by the p. And then over by QSR, you do 3 times 35, which is 105. And then to get the PSQ, you do 180 minus 105. And then you add that up with 35. And then you subtract that from 180, and then you get 70 for that little corner up there.
Beautiful. Really well done. Really, really well done. I love it. The idea that when we have a straight line like this, if this is 105, then this has to be 75, because the two angles around a straight line like that, this has to be a total of 180 degrees. Really well done there. Everybody comfortable with that solution? Because I'm about to erase it and show you guys a totally different solution. Give me a smiley face if you're totally comfortable with the way that Caitlin did this problem. And I'm assuming that's what probably everybody did to solve this problem. Anybody do anything different? Anybody do anything different at all? Oh, Emma, tell me what you did. All right, we call this the exterior angle of a triangle rule. Here's how the exterior angle of a triangle works. Let me draw a new triangle just so you guys are going to be able to see this a little more easily. So I'm going to redraw this, and I'm going to make it a pretty similar triangle. A little bit different, but whatever. Pretty similar triangle. Here's the idea. Let me call this angle X, and let me call this angle Y. Okay, and now I'm going to call these other two angles A and B. So the triangle rule tells me A plus B plus Y equals what? Three angles in a triangle, what do they add up to? All right, 180. But because X and Y are two angles around a straight line, what do they add up to? So if A plus B plus Y is equal to 180 and X plus Y is equal to 180, what must be true? Yeah, these are equivalent. These are equivalent to each other. A plus B is equal to X. So going back here for a second, we can recognize that if this angle down here is 3x, right? If this angle down here is 3x, then we know that these two angles over here are going to have to add up to 3x. Well, how do we get to 3x with x plus something else? It's got to be 2x. And if x is 35, then 2x is 70. And that's a little bit of a shortcut for that problem. It involves doing it basically in 2 steps instead of 3. Now, I don't care how you solve this particular problem. I think Caitlin's solution was great and showed a good understanding of the relationship between angles in a triangle. But I do want you guys to know this exterior angle rule, because you'll occasionally run into a problem where that truly is the best or even the only solution to the problem. Situations where it's hard to recognize how to jump from one angle to another unless you see the exterior angle. All right. Any questions about the exterior angle rule? I'll leave this slide up for just a second, but you guys tell me, any questions about it at all? Okay, fantastic. I've got another problem for you guys. Here we go. Triangle plus another shape. All right, I've only got one answer so far, so I want you guys to keep working on that. And if nothing else, take your best shot at it. And meanwhile, Emma, why don't you start talking to us about this problem? What did you think about this problem? How did you solve it? Where did you start? I would agree with that, so let's figure that out first. So it's going to be 1/2 of 3 times 2, right? 1/2, I'll draw it all the way out, but you're right. 1/2 of 3 times 2 That's going to be 3. So quantity A is 3. Okay, good. Keep going. 30, 60, 90. You're absolutely right. And unfortunately, this is one we just have to memorize how it's working. I can show you how to derive it, but it's important to have it memorized because in this case, they've only given us one angle and one side. So we can't immediately use the Pythagorean theorem because we don't know 2 of the 3 sides. We have to have memorized the relationship in a 30, 60, 90 triangle. So what's that relationship, Emma? All right, so the hypotenuse has a very simple relationship with the short side. So the short side is the one opposite 30 degrees. The hypotenuse is double that. And then the side opposite the 60 degrees is the short side times the square root of 3. So in this case, 2 square root of 3. So what did we say the square root of 3 was? Because I'm going to need an actual number here. So this is going to be roughly 3.4. Do you guys agree with me there? Yeah, Jignasha, totally correct, but we don't need it past 1.7. 1.7 is more than enough. Don't make your life any harder than it needs to be. 1.7, I've never seen a problem where that wasn't good enough. Okay, so Emma, keep going. What's the area of this triangle? Yeah, you're right. Absolutely. We don't need to calculate it. If we need to, we can write it out, but it's 1/2 base times height. We can make 2 the height and 3.4 the base. And look, these numbers are exactly the same, except there's a difference between 3 and 3.4. And 3.4 is bigger than 3. 2 and 1/2 are the same. So the answer for this problem has to be B. Very, very good job on that. All right, so here's what we need to know for a 30, 60, 90 triangle. Whatever the small side is, whatever the short side is, the hypotenuse is double that side. And the long side is that short side times the square root of 3. So the ratio of 30, 60, 90, if you guys want to think about it as a ratio, is 1 to root 3 to 2. Now, I don't have time to take you guys through this, but one really useful exercise is to prove why this works. And the easiest way to prove why this works is to start with an equilateral triangle and call each side of the equilateral triangle something like 2x or 2a, something along those lines. Then cut the equilateral triangle in half and see what happens with the Pythagorean theorem. And you'll discover this ratio right here that you need to memorize. What's the other one very similar to this that we need to memorize? Almost exactly the same basic concept. It's this triangle right here. Pretend for a second that I actually had drawn this as a right triangle. But in this case, if I call the 2 sides x, what's the hypotenuse? The 2 legs are x. What's the hypotenuse? Right, x root 2. And if we're going to write it the same way we wrote the other one, in a 45, 45, 90 degree right triangle, the ratio is 1 to 1 to root 2. Just flat out memorize both of these. They come in very, very handy on this test. All right, questions at all? Okay, we're going to move on to circles next. So let's do this quick. Type in. Fastest one to type it in wins. What's the circumference? Nope, not 14. Not 14. There you go, 14 pi. Be ready to work with this quickly. We know the area is pi r squared. And so that means that if we've got an area of 49 pi, we just need to take the square root of the number and drop the pi. Things get a little more complicated if they give us a weird area, like let's say the area was just 49. But then we could plug it into our formula and figure out that we need to divide by pi and take the square root. We'd still be able to do it. It would just be uglier. But in this case, we want to just be able to say, oh, the radius is 7. And once I've got the radius, I double it and multiply by pi. Get good at this. There's one final thing that's worth knowing, which is the diameter. How do I get the diameter? What do I do to the radius to get the diameter? Yeah, I just double it. So really, another way to think about it is the circumference is simply the diameter times pi. But usually people like to think about it in terms of the radius. That's kind of a modern change. The ancient Greek mathematicians always talked about the circumference as being the diameter times pi. But we often in high school learn it, or in middle school learn it as 2 pi r. It doesn't really matter. The point is, if I know the radius, I know the diameter, the circumference, and the area. If I know the diameter, I know the radius, the circumference, and the area. If I know the circumference, I know the radius, the diameter, and the area. And if I know the area, I know the radius, the diameter, and the circumference. So that's what's cool about a circle. These 4 basic concepts, these 4 basic measurements, as long as you know one of them, you are guaranteed to know the other 3. Now things get a little bit more complicated when we deal with parts of circles, and we'll get to that in just a second. But keep in mind what I just said about how you can use any one of these 4 to get the other 3. And a lot of circle problems are just about figuring out which one you need and what you need to do to get there. So let's try a problem out. Here we go. Good luck. 2 minutes. Okay, guys, I've got a couple of answers in, and by the way, the 2 answers that I've gotten in out of the 4 of you are correct, so well done. But I think a couple people still working on it. This is kind of a challenging problem. Jignasha, why don't you talk to us about how you solve this problem, and feel free to hop on the mic if that's easier. Jignasha, you there? You want to tell us how you did this problem? Okay, so what does that tell us about the square if the radius is 1? Beautiful job. Really well done. Jignasia did a great job there. The point of this problem is to show you guys how sometimes you have to step from one piece of information to the next, to the next, to the next, until you get to the final answer. And in this case, what we had to do is we had to use the small circle, because that's the only thing they told us anything about. We had to use the small circle to figure out something about the square. And we had to use the square to figure out something about the big circle. And then once we figured that out about the big circle, we were able to solve the question, which is the area. But to get the area of the big circle, we needed its radius or its diameter or something along those lines. So good job. Any questions about that problem at all? That's a clever problem, isn't it? It's almost, if you stare at that original shape too long, your eyes start to go all wigged out. It's almost like an optical illusion, but that's the idea. We use one piece of information to get the next piece, to get the next piece, to get the answer. No single step we did here was difficult. In other words, if I just gave you the small circle and told you it was area pi, you should be able to figure out that its radius is 1. That's something that we should always be able to do. The challenge, and what Jignasia handled really well, isn't the single steps, it's linking all the steps in the right order to get us from the beginning of the problem to the end of the problem. That's what the real skill is. Not the individual steps, but being able to link them all together in the right order to get from the start to the finish. Well, you know, if you think about it, it has to be, because the center of the circle, of the small circle, since it's exactly inscribed inside the square, then the circle inscribing the square also must have the same center. And since both circles have the same center, that means they are concentric. So yeah, we can, I wouldn't say assume that, but we can agree that that is true. We can agree that that is true. In other words, if they weren't concentric, if the big circle was not concentric, then it couldn't actually end up being, if its center was different from the center of the small circle, let me choose a better color there, then it wouldn't actually be able to inscribe the square. But good question. Yeah. Okay, questions at all? I got one more minor thing to talk about with circles, and then we'll move on to polygons. Try this one out. Oh, and that's a little bit hard to read, so let me rewrite this real quick. But that's A right there on the edge. Okay, so you guys tell me the length of minor arc AB. See the fastest to type it in. Okay, nobody's typing it in yet. All right, what's the relationship between the center angle formed by two radiuses and the circle as a whole? How many degrees are in a circle? Let's just start there. 360 degrees in a circle. So 60 degrees is what fraction of that? Okay, so if this sector, I'm going to put an O in here, OAB, that sector there, what's its area in relationship to the area of the whole circle? Forget the 9 for a second. Just think about dividing this guy up into pizza slices, or dividing it up into a Trivial Pursuit board. Do you guys play Trivial Pursuit? This is what the wedge looks like for Trivial Pursuit. And I'm going for something way simpler than that. Yeah, I mean, you guys are getting numbers. I don't care about numbers right now. Forget numbers. Every one of these little pie wedges that I just drew, every single one of them, right, is what part of the area of the circle? What part of the area of the circle? Yeah, and that's all I'm going for. 1/6, 1/6, 1/6. There's 6 equal parts here, 6 equal pie wedges. 1/6, 1/6, 1/6. Well, the same thing happens with the minor arc AB. It's 1/6, but it's not 1/6 of the area. What is it 1/6 of? The circumference, right. So what's the circumference with this problem? Okay, we got to be careful. It's 18 pi, not 18. What's 1/6 of 18 pi? 3 pi. And it's actually pretty important that we called it the minor arc. Why is it important that we called it the minor arc? Friends got it. There's actually two ways to get from B to A. We can go around this end, or we can go this end. Yeah, and so that 60 degrees, that arc from A to B, could actually be 15 pi, 1/5 pi. The major arc is 15 pi, the minor arc is 3 pi. So they have to tell us whether it's the minor arc or the major arc. It'll almost always be the minor arc. All right, cool. Good job on that, guys. Let's try a problem out. There's two ways to do this. One based on something we did very early in class, and another based on the rule that you just learned. So give this one a try, and we'll talk about it. Good luck. Okay, I've only got one answer. Two answers. Caitlin, start telling me how to do this.
Well, I kind of guessed because the timer ran out, but I started out trying to figure what the angle would be for POQ, and I was a little confused. I didn't know when you said O is the center of the circle, if that line was like right at the center or not. So I assumed it was. So then I did 30 and then 30 degrees for PQO, which would make this 120 right in there. And then on the other side, it would be 60 degrees. So then you would know that it's 1/6 of the circle. So then it turns into the same problem we had before with the numbers. So it would be 3 pi, which is small.
Really well done. Really well done. Hopefully everybody followed that. What Caitlin did is she realized that if this angle is 30, this angle has to be 30 as well because this is an isosceles triangle. That gives me the 120. The 120 gives me the 60 because they're a line dividing a straight line. And that gives me 60 degrees being 1/6. So the circumference being 18 pi, this is 1/6 of the circumference, 3 pi. And if you think about it, pi squared is pi times pi, right? So it's basically pi times pi, so the only thing we're really paying attention to here is 3 versus pi. Which one's bigger, pi or 3? Pi, so this has got to be bigger. Very well done. All right, I'm going to show you guys real quickly a completely different way to do this problem. Remember the rule we talked about at the very beginning of class. If this is 30 degrees, and it's 2 chords inscribed on a circle, then its angle measurement is half the enclosed arc. So the enclosed arc from Q to R is what? If this is 30 right here, this has to be 60, which is 1/6, and that gets me right back to 3 pi. And that's just a shortcut where I can use this rule right here. And honestly, if I do it that way, I can ignore the line from O to Q. But if I do it the way Caitlin did, I need to think about this as a triangle and use it to get the angle at QOR. Either way works great. Either way works great. Questions at all? All right, not seeing any questions. Let's talk about polygons for a little bit. I got two more subjects to cover, and then we will turn it over to reading comp. One of them is polygons, and the other one is the exciting field of coordinate geometry. Woohoo! But polygons really just mean shapes that, have a certain number of sides. So a triangle is a three-sided polygon. A square or a rectangle or a parallelogram or a rhombus or a trapezoid is a four-sided polygon. A pentagon, like we have here, is a five-sided polygon, and we can have bigger and bigger numbers of sides if we want. What does it mean for them to call this a regular pentagon? That's the most important word here. And honestly, when you start dealing with shapes that have more than about four sides, they usually tell you it's a regular pentagon. Anybody know what that means? Yeah, all sides are equal and all angles are equal. All sides are equal, all angles are equal. And so exactly how we've drawn it here with these 5 x's and these 5 sides that are equal. Okay, so tell me how to figure this out. How do I know what each individual angle is? I'm going to need to know what? To figure out what each of these individual x's is, I need to know what? Yeah, and Catherine's got the formula. Let me show you guys this. A triangle has 180 degrees. A square or a rectangle or any four-sided figure has 360 degrees. And by the way, that's true no matter what. I can draw a really crazy, like Star Trek communicator symbol. All 4 angles there, here, 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 and here, must add up to 180 degrees if those are all straight lines. That's kind of cool, isn't it? It doesn't look like it, but all 3 of those tiny angles are going to add up with the big obtuse angle to make 180. It's true for any four-sided polygon. So what do you think the next number is going to be? 180 for a triangle, 360 for a four-sided figure. Catherine's got it. Every time we add another side, we're going to add 180 degrees. So for instance, a 6-sided figure is 720. A 7-sided figure is 900. An 8-sided figure is 1080. Right? And so on and so on and so on. But maybe it's easier to just think about this formula, n minus 2 times 180. So for a triangle, 3 minus 2 is 1. 1 times 180 is 180. For 5-sided, it's 5 minus 2 times 180. Personally, I watch a whole lot of sports, including things like crazy sports like trick bicycle riding and stuff like that, skateboarding, stuff like that. And this is basically the number of turns they do. So if they do 1 turn, it's 360 degrees. If they do a turn and a half, it's 540. 2 turns is 720. All right, so when you hear like, oh my God, like Tony Hawk just pulled off a 720, that's what he means. And that's how I remember the numbers. But this formula here works really good as well if you don't follow a whole lot of those kind of X Games type sports. And now I've lost everybody because everybody's probably sitting there going, who the hell's Tony Hawk? But that's okay. I watch, and as Liz will attest, I watch an awful, awful, awful lot of sports. All right, so let's try this out, a quantitative comparison problem. This is a fun one. Take the standard minute and a half, and let's see how it goes. Interesting. We've got some disagreement here. We've got some real disagreement here. That's interesting. So the triangle and the square have the same perimeter, and we need to know the area of each. Same perimeter. That's interesting. Now, you could choose numbers and prove this. if you wanted to, as long as you chose good numbers. So for instance, we could do the square, and we want to choose numbers for the square that make it easy to do a triangle. So maybe I'll do 3, 3, 3, 3 to get a perimeter of 12. And that means that in the triangle's case, what are the sides going to be equal to? And I'm going to make my life easy and make this an equilateral triangle. But what are the sides going to be equal to? Yeah, now they're all going to be 4. 4, 4, 4. And I know a lot of you guys might be thinking, why don't you make it a right triangle, because that'll make it easier to find the area. But the problem with making it a right triangle is it's actually going to be hard to choose values that are all going to be integers. And I'll show you guys a way around that in just a second. But it's actually going to be hard to do that unless you know a cool little trick. So what we're going to end up with is doing this, right? And then now that this is 2, what did we learn earlier? What's that height going to be? This is a 30, 60, 90 degree triangle. When I cut it in half, what's the height going to be? Yeah, the height is going to be 2 root 3. The base is still going to be 4, so it's going to be 1/2 4 times 2 root 3. Okay, this one's easy. The area of the square is just 3 times 3. That's going to give me 9. Okay, everybody comfortable here so far? What's bigger, 1/2 4 times 2 root 3 or 9? What's bigger? Now the 1/2 is going to cancel out with the 2, so it's really just 4 root 3. What's bigger, 4 root 3 or 9? You guys tell me. 9's bigger because root 3 is smaller than 2, so 4 times it's going to be less than 8. So this answer is going to be B. And by making this an equilateral triangle, I actually made this the largest possible area I can make out of that shape, or one of the largest. Now, another way to have done this would be to do it as a right triangle. And if I'm really clever, I can recognize that I can do a 3, 4, 5 right triangle and also get the same perimeter. And then I'm getting 1/2 base times height, so it's area of 6. But that's not actually the largest possible area here. So I'm worried about that. Okay, all of this is complicated and hard math. Here's the easy way to do this. If your perimeter is equal, then more sides mean bigger area. So in other words, a triangle is smaller than a square, is smaller than a pentagon, is smaller than a 50-sided figure, is smaller than a circle, given the same perimeter. This only works if they all have the same perimeter. But a triangle with perimeter 12 is smaller than a square with perimeter 12, is smaller than a pentagon with perimeter 12, is much smaller than a circle with perimeter 12. The circle gives you the most area for a given amount of perimeter, or in the circle's case, circumference. Isn't that kind of a cool rule? Isn't that kind of a cool rule? And that's something you can use in the future to avoid having to prove all of this stuff to yourself on the day of the test. And by the way, it works backwards as well. If a triangle and a square both have the same area, the triangle has more perimeter to get that same area. The square needs less perimeter to get the same area. All right, let's keep moving on. Let's try some problems out. I just have 2 for you here. I'm going to give you a total of 3.5 minutes to do this pair. Good luck. If I can get the timer working, sorry. Okay, let me see the answers to the first one. I get no answers from anybody so far, but ring in for the first problem, this polygon here. Now, notice that shape looks like it might be a rhombus or a parallelogram. Do we actually know that? Yeah, we don't really know anything about this shape. This could just as easily look like this, right? Keeping B and D in the same place, but changing AC. That could just as easily be the case. Is there any way to figure out, without being told anything else, which diagonal is longer? We can stretch. Remember rubber band geometry. We can stretch things out. We have no idea that this shape looks like this. So you guys are 100% correct. D is the answer to this one. This is a great problem to spend very little time on once you recognize no angles, no lengths, no description of the shape. All I know is it's a four-sided figure. That's all they've told me. All right, very good job. How about the second one? Let me get you guys to ring in your answer choices for the second one. I'll clear them and you guys tell me. Ooh, I got a vote for D again, a vote for A, and a vote for B. And another vote for A. Interesting. All right, let's deal with quantity A first. If it's a cube, that means every side is the same. That means every side of the cube is a 3 by 3. How many sides does it have? Think about rolling a die if you're playing a board game. Yeah, there's 6 sides to a cube. So we know that this side is 6 times 9. This side is 54. Does everybody agree with me there? Okay, the other one's the slightly harder one to deal with, so I've sort of drawn it as well as I can. Let's call this 2, we'll call this 4, and we'll call this 3 right here. How many sides does this shape have? Still got 6. But what we got to realize is those sides are different now. We have 2 of each type of side. So for instance, we've got a side that's the top, and we've got a side that's the bottom, and they're going to be the same. And the top and the bottom are each going to be a 3 by 2 rectangle. Think about pulling that top and bottom out. We're also going to have a left side and a right side. The left side and the right side are each going to be a rectangle that's what measurement? What do you guys think the measurement's going to be for the left and the right sides? Anybody know? 4 by 2. Yeah, you're totally right. It's going to be 4 by 2. And finally, we've got a side in the front, right? And we've also got a side in the back. All right, so front and back are each going to be what? 4 by 3. You guys are on fire. There's going to be 2 of each of these. So I'm going to have 2 6s, 2 8s, and 2 12s. Add that all up. Is it bigger or smaller than 54? Yeah, it's smaller. Now, what would have been the quicker way to do this? Think about a slide we looked at a few minutes ago. No worries at all. Yeah, it is A in the end. Think about this. A triangle, right, better than a square. And by the way, it's not in here, but a square better than a non-square rectangle, better than a non-rectangular pentagon, blah, 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 blah. It also works in 3 dimensions. A cube is going to have more volume and also more surface area than a rectangular solid that has the same total side length. So if you think about it, 3 by 3 by 3 is the same overall perimeter side lengths, it's really not perimeter because it's three-dimensional, but the same side lengths is 2, 3, 4. They both all add up to 9. But given that, the surface area and the volume of the cube is a more perfect shape. It contains more than a rectangular solid. To make that rectangular solid bigger, I have to make it 3 by 3 by 4, 2 by 3 by 5 or something before it gets bigger. All right, questions at all before we move on to our last topic here of the day, well, of the math day. Okay, moving onward. Let's talk a little bit about the coordinate plane. You guys tell me, what is the slope of this line, 4x minus 3y equals 6? What's the standard way that we're given a slope? What's the standard equation the slope is given to us in? All right, so tell me what M and B are. We'll get there in just a sec, but I think I agree with you, Caitlin. Tell me what M and B are first, though, before we do that. I do not agree with I'm sorry, for this particular problem. We'll get to that in just a second, Catherine. We'll get to that in just a second. B is not actually 6, though. Just tell me what M and B are in this point slope formula. What does M and B mean generally? Not in the original question. Sorry, I'm phrasing that wrong. Yeah, M is the slope, right? And what's B? B is the x-intercept, or y-intercept in this case. And the reason why B is the y-intercept is because if x was 0, when x equals 0, what does y equal? B. So where is x equal to 0? Tell me where on the graph x is equal to 0. Well, that origin is where both x and y are equal to 0. Where is x equal to 0? X is equal to 0 on the entire axis of x. All along that pink line, x is equal to 0. Now, y might be over here, right? Y might be up here, y might be right here, y might even be right here like it is in this particular problem. But everywhere along the pink line, along the x-axis, x is equal to 0. Just like everywhere along the y-axis, y is equal to 0. So that's why we call B the y-intercept. Now, the slope is basically a way of measuring how much distance a line travels vertically versus how much distance a line travels horizontally. Call that rise over run, right? Rise over run. Okay, so now let's solve the problem. What I want to do is I want to do algebra. I want to transform 4x minus 3y equals 6 into my standard point slope formula. So what do I need to do? I need to isolate y. So I'm going to have negative 3y is equal to negative 4x plus 6. Now I still need to isolate y. So I'm going to divide by negative 3, and that's going to give me positive 4/3 x. But what's it going to make b? Not positive 2, negative 2. And that's exactly right here where it's crossing the x. So this is negative 2 for the intercept, and then the rise over the run is 4/3. Think about how that works. Just count. Counting is sometimes the easiest way to do these problems. What I'm really saying is from any point on the line, if I go 1, 2, 3, 4 up, 1, 2, 3 over, I get to a new point on the line, right? Rise and run. 1, 2, 3, 4 up. 1, 2, 3 over. I'm still on the line. That's what we mean by rise over run in the most sort of visual and obvious and non-formulaic way. Now, of course, there's all sorts of ways to figure this out algebraically, but sometimes the easiest way to figure this stuff out is just to look at the picture and understand what's going on. Okay, any questions so far? All right, we're going to wrap up here in just a second, but I do want to show you guys some basic slopes that you should know. A slope of 1 means the line goes up 1 and over 1, right? Up 1, over 1, up 1, over 1. And so that's what this looks like. And it means it's going up and to the right. It's positive. The negative version of that slope would be this right here. Up but to the left, right? Up is positive, left is negative. So positive, negative, positive, negative, right? Or you can think of it as down and to the right, down and to the right, negative, positive. That's why this slope is negative. So negative slopes go this way, but positive slopes go this way. Everybody comfortable with that? All right. The cool thing about slopes is slopes simply tell us what the line's rise and run is. They don't actually tell us where the line's located. So the slope over in this example, right, is exactly the same as the slope here. They both have a slope of 1. They're the exact same line. They're parallel to each other, in fact. But this line has a different intercept than this line does. So they're located in different places, but with the same slope of positive 1. All right, let's get a little bit more complicated here. Here are some slopes that are a little bit different. So let's take a look at the top left one first. This line is steeper than a slope of 1. So let me show you again what a slope of 1 would look like. A slope of 1 means it is going up 1 over 1, up 1 over 1. This line right here goes up more than it goes over. So its rise is greater than its run. So its slope has to be greater than 1. What kind of line would it look like if you had a slope less than 1 but still positive? I'll use a purple line for that. That would look something like maybe like this, right? Now all of a sudden we've got it going just up a little bit but over a lot. Up a little bit, over a lot, right? That would be a slope that's positive because it's still going up and to the right, but it's shallower, so it's less than 1. All right, everybody comfortable with that? Okay, so in the negative side, think about this one over on the top right. This is a shallow slope. It's shallower than a -1 slope. Because it's shallower, it's going up less than it's going over. So it's a negative slope, but it's got a bigger denominator, a bigger run than numerator, rise. So since the denominator is bigger, it's a fractional number. It's a negative fraction, but it's a fraction nonetheless. Everybody comfortable with that? Give me a smiley face if you're getting all of these. And then the last one, this last one at the bottom middle is actually a steeper. It's steeper, but it's still to the negative. That means that its rise is bigger than its run. So its numerator is bigger than its denominator. That means it's bigger absolutely than 1, but since it's negative, it's smaller than -1. So the great thing about this is if you can recognize these, you can figure out problems very, very quickly. All right, I want to show you 2 more. We'll do 1 problem, and then we'll take a short break. 2 more, and that is just the fact that parallel lines have the same slope. So if I tell you that this line here is parallel to this line here, and I tell you the top line has a slope of, let's say, 2/3, what's the slope for the second line? What's the slope for the second line? If these are parallel, line 1, line 2, line 1 is parallel to line 2, what's the slope of line 2? Anybody? If they're parallel, what's true? If line 1 is slope of 2/3 and line 2 is, yeah, it's the same. All right, that's easy. Here's the hard one. I'm going to draw a third line here, and I'm going to tell you that this is line 3. Okay, line 3 is now perpendicular to line 1. What's the slope of line 3? Catherine's got it, -3/2. A perpendicular line is the negative inverse of the slope of the line that's perpendicular to. Good job. And it has to be negative because if it is perpendicular, then one of them's positive and the other's negative. And it's the inverse of it as well because it's 90 degrees off of it. So it's rotating 90 degrees, which means its rise and its run are changing. And you can prove that to yourself by drawing some pictures. All right, here we go. I apologize, guys. I was drawing all these pretty pictures for you, and you weren't seeing any of them. But this is what it looks like. Wow. So, Catherine, good job doing that in your head when you didn't have my picture to show you. Really well done. Okay. I think we're actually good for now. I think we're actually good. There's potentially one more problem that I'll come back to later next week. But I think we've done a good job. I think we've beat geometry into submission, and I think that the reading comp that we're doing today is also very important. I want to give Liz at least a full hour to cover reading comp for you guys. So really good job on the geometry. You guys worked on it really, really well. And I think we're going to take a 5-minute break here and then come back and do reading comp. So 5 minutes, and then we'll talk about reading comp. See you back in a sec.
All right, everyone, come on back. Let's get started on reading comprehension. Okay, so how many of you are into reading comprehension? Just a show of smiley faces. Let me know where you are. If you're not so into it, you can put up that funky gray face with a squiggle smile. But let me know who's into it. Okay, so a mix. Kind of divided, some into it and some not. Okay, so for those of you who are into it, this may give you some new ideas. For those of you who are not into it, this is going to give you a way to tackle these questions. All right, I like to think of RC as a spectrum, and I like to think of people as either primarily gatherers or primarily hunters. You know you're a gatherer if you read for detail. All right, you read every little thing, and you're very careful to note every detail. You know you're a hunter if you say, hey, this is a standardized test. The point is to answer the questions, and you read the question first before you even bother to look for look at the passage and then go search the question for the answer. Both approaches have their merits, but we're going to try to focus on sort of a middle ground approach where you're somewhere between a hunter and a gatherer so that you can get the benefits of both. In order to do this, we're going to really focus on the structure as we read and try not to get lost in the details. These passages are academic passages. They're quite detailed. And so if you need a detailed piece of information, you're generally going to have to go back. And our goal really is just to know where to go back. Okay, rather than to memorize all the details. Okay, so what I'm going to talk about is a method of diagramming. All right, And I will tell you that for very easy passages for me, if the passage is short or if it's a topic I'm very comfortable with, I tend to do less diagramming. However, if it's a long passage or a passage that I'm not so comfortable with the topic of, I tend to do more diagramming. And the reason that I do this is that it really helps me to see the overall structure and not get lost in the details. Typically in these passages, the first paragraph is very important. It sets things up, all right? And so I typically want to read it for detail. The subsequent paragraphs are less important. I need to know their purpose and their main point, but I don't need to remember all of the details. So what I'm trying to do is to read it and to get a headline or a main point for it, and not to get lost in all of the details. When I take notes, I'm not writing a book. I am not writing anything that's going to be inspected by my high school teacher. Okay. I typically am going to abbreviate because I only need to remember this for a few minutes. And if there's a really long scientific name or something, deoxyribonucleic acid, I'm going to write DNA. See, I even knew the variable for that one. But if it were something I didn't know, I'd still assign a variable name or even a letter. If it's some scientist name or if it's an interesting theory in philosophy or something, I'll assign a letter, okay? Because I really want to focus on the structure and think about the main idea. Now, some tips on main idea, okay? Main idea is not the same as the topic, all right? My topic could be the budget deficit. I could be writing about the budget deficit, but I could have very main ideas, all right? I could be a very different main ideas. I could be a budget hawk and think we must close this deficit at all costs, and then that would be my main idea. Or I could be a deficit dove and say, no, a deficit is sort of a fictional thing for a country. We must manage we must manage spending so that we, maximize society's well-being and prevent a Great Depression, okay? My topic in both cases would be the same, but my main idea would be very different. So often you get an idea of the topic in the first paragraph, and then there's some kind of a twist that'll really give you the main idea in the second paragraph. Or sometimes it's just the first sentence. They give you this sort of general thing, and then you get the specific main idea afterwards. Okay, that's just a very common structure in academic articles, so we're going to be looking for that. Sometimes in a very long passage or in a very creative writer's passage, the main idea could come even later. It can even be at the very end where you're sort of surprised by it. Okay, it's supposed to be some kind of reveal. If it's something like this, it's really important to take the notes. The longer it is, the better, as Ian is saying, because our short-term memory is so lousy. And so it is really helpful to sort of follow the train of thought going through the passage as we're looking for the main idea. What is a main idea? Okay, a main idea is not just the topic. Okay, a main idea is something, it's more of, you can think of it as the author's purpose. It could be the resolution of a problem or the answer to a question. A lot of the ones on the GRE are a twist or a change. A new idea versus an old idea, or a realization, some kind of a refinement of an idea. I think this is because so many of these passages come from academic writing where you're always referencing previous work or the mainstream work and adding a new twist, a new idea. Sometimes we also see just explanations that's straight out textbook kind of writing explaining why something is. And then sometimes you see something that looks like a legal brief almost. You'll see a judgment call, and it's not necessarily about the law. All right, it's the author laying out the options and then giving an opinion. All right, but they're all kind of academic. All of these main ideas are sort of academic. So I want to show you a passage, and you can predict, by the way, from the way it's set up, what you're going to be looking at. I want to show you the first paragraph of a passage. Okay? All right. Typical passage. Why don't you guys take a moment and read it? And as you read it, tell me what makes it kind of hard to read. There's a really noteworthy feature, typical of academic writing. Okay, let's see. Show of smiles. How many found this straightforward to read? Easy to read. I gave you a minute, which is more time than you would actually have for something this length. How many of you found it straightforward? Give me a smile. Not so straightforward, give me a thumbs down. Okay, great. I've got 3, 4 smiles. Okay, we were able to read it comfortably. If you take your time, you often can read them comfortably. So what did you use to break it down? What in this passage or this paragraph lets you break it down? The commas. Exactly, Jignasha. The sentences are really long, but the thoughts are separated out by commas. So what I do when I read this kind of thing, and I read tons of this kind of thing in my PhD, is I use the commas to parse. And I read it out loud to myself. I read it under my breath to myself. My lips are actually moving when I take the GRE because it helps me to parse it. I don't know what Ian does, but I find that it is much, much easier if I do it that way. Okay. When the sentence structure is complicated. Anyone here? Anyone else have lips moving while reading this thing? Yeah. Okay, so people who read a lot of academic writing often take this approach. Sometimes unconsciously, absolutely. It just helps you track what it's saying, and that's really important. Okay, the parsing. We've got this current feminist theory in validating women's own stories of their experience has encouraged scholars of women's history to view the use of women's oral narratives as the methodology next to women's written autobiography that brings historians closer to the reality of women's lives. If this is the opening sentence of a passage, what do you think the rest of the passage is going to be about? All right? You can predict from here. You can get a good idea. What's the rest of it going to be about? Well, but more specifically, I'm writing as an academic, and I talk about current feminist theory does X. Okay? What am I going to do? Am I just going to continue talking about that? What am I going to do? I mean, if I'm an academic and I'm writing this, I say current feminist theory does X. Okay? The narratives and how they use the methods. Okay? Now, has encouraged. All right? Look at this. Okay? So I could talk more in detail about exactly how they do this. Absolutely. I could talk more in detail. What else might I be doing? What else might I be doing if I lay out what the current state of the art is, the current theory? All right, I'm writing my dissertation. I have to start this way. I talk about the current theory. What am I going to do? Anyone? It's really helpful to understand how academics write. Okay. Well, I could give a history of past theories. What else could I do? What else could I do, which is actually more common? Future theories, new theories, right? I could go forward. Okay. If it were my dissertation, I'd trace the whole history of thought. That's true. But in a typical academic article, I might want to talk about future theories or a hypothesis. I might want to add something different. Okay? So we saw the first paragraph. Let me show you the actual second paragraph. All right? What's the second paragraph doing? Here, I'll put up another minute and I'll stop babbling so everyone can read it. Now, what's this second paragraph doing? We had the first paragraph, which told us about the current theory. What's going on in the second paragraph? All right, this is a really common pattern on the GRE. What's going on? I told you the state of the art. What's next? Or the current state of the theory says X. Contrasting. Emma has it, okay? Caitlin, telling us to be cautious. Catherine, you have it, but it's a little more narrowly focused than I want you to be right now. All I really want you to realize from this is that this is a contrast. This is what we call a twist, all right? And there's specific words that often signal a twist. And you want to go highlight words. What are the words in here? That if you see these words, you should think, aha, the twist is coming. Grab the, oh, that's the pointer here. Grab the, this thing, the orange thing, the highlighter. Grab it. Let's highlight some of the magic words, the thick orange thing. However, excellent. There's some others. Okay. Cautious maybe goes along with it, but there's some other words. Okay. How about moreover? However. What does moreover mean? It's a word you only see in academic writing. What does moreover mean? What does moreover mean? See, these are the words. Furthermore. Exactly. Thank you, Caitlin. These are the words that tell you, aha, the big twist is in here. Okay? These are what I think of as trigger words. They tell you, pay attention now. Another thing that's very useful are to notice these words that give examples, like for example, and that come up with a conclusion. Thus, some sort of conclusion. Okay? Examples, illustrations. All right, something that's supposed to make the point more clear, okay? So if you look for these signal words, you can really figure out the purpose of the paragraph. You can say, aha, it's the twist paragraph, and know where to look in it for anything, you know, that you might need. They might ask you about specific examples, or they might ask you about the broader big picture issue. Okay, so learning to note trigger words. If you struggle with these passages, learn to hunt trigger words. Because if you've thought about this structure, okay, so first paragraph lays out, you know, what the current theory is. Second paragraph has a twist and says, be cautious about doing what the current theory says to do, because you can look at this and go right to the correct paragraph. According to the passage, scholars of women's history should refrain from doing which of the following? Where should I go to find the answer? All right, even with it not in front of you, where should I go to find the answer? Okay. Jignash is typing, yeah, second paragraph. All right, and this may seem like a silly exercise, but speed is critical on the GRE. And if you are able to break the passages down structurally and figure out, okay, what's it doing in each paragraph? What's going on? You know, what's the author's point and what's the purpose of each paragraph? You'll be a lot faster at locating answers. You'll be much faster than a hunter who has no knowledge of the passage when we went back. Now, it might make more sense looking at my spectrum. You won't be hunting blind. You'll have done enough reading so that you'll be hunting with a map, okay? And that's really our whole purpose in doing this initial reading. We can't remember, we're unlikely to remember all the details, but we want to be able to hunt with a map, okay? So now we're going to try it, all right? Does everyone have the RC handout? Okay, Ian mailed it out. Check your email. Smile at me if you have your RC handout. If not, you can download it off of your Student Center. But everyone's going to need this. If you don't have it, please message Ask for help. It should be in your email. Okay, if you don't have access to your email, try downloading. Cargo cults, exactly, Catherine. It's about cargo cults. So now what we're going to do is we're going to try this. We're going to create our structural map of this passage, okay? And we're going to take 3 minutes to do this, okay? It shouldn't be too difficult now that we've practiced it. Again, typical kind of academic passage. Here you go. So create your map. The cargo cult handout. Okay? Sorry, Jignasha. Everybody make sure you have the cargo cult handout. All right? That's what you should be reading. And you're creating the skeletal sketch that I talked about. You're using the commas to help yourself parse. And you're figuring out the purpose of each paragraph. What's going on? You're making a map. All right, how many of you were able to get through the passage? Smile if you were able to read through it and take your notes. Okay, thumbs down or let me know if you weren't. Okay, it looks like most people got through it, all right? So we're going to really think about it. Let's think about it first. In terms of your notes, what is the first paragraph saying? This first paragraph, which is pretty important, which sets it up, what's it talking about? What's it talking about? All right, if we were to try and summarize, what is it saying? What is that first paragraph saying? Explains the origins of cargo cults. Yeah. Caitlin, exactly. I would agree. Anyone else? There are different ways to do this. Okay. What does it do? It doesn't just, it's pretty specific in terms of how it explains it. How they gained prominence. Okay. All right. The thought process. I love what Catherine is saying, the thought process behind a cargo cult. So from this first, yeah, this is very close, okay, to how I was thinking about it, which isn't the only way. But yeah, I would say that as you look at it, okay, the cargo cults tried to make cargo by copying the U.S. They thought the cargo was really theirs. You know, it was the thought process. Okay, this was Catherine's point here. Okay. And Caitlin here, they tried to make cargo by copying the U.S. All right? So you know now what a cargo cult is. What happens in the second paragraph? What's the purpose of it and what's it talking about? What does the second paragraph talk about? All right, the second paragraph is quite different from the first. Okay, it's not really about beliefs. Okay. What's the second paragraph about? What's it doing? Yeah. Emma and Catherine have it. It's really about this idiom, okay? It's an idiom for people who mimic actions without doing the real thing, okay? So cargo cults, the term came about because of these people who were trying to make cargo by copying the U.S. All right, so excellent. What purpose does this second paragraph serve? First, I explain historically what was called a cargo cult. And now I talk about it as an idiom. What's going on? Okay, am I really giving, just a straightforward history of people living on these remote islands? What am I doing when I talk about the idiom? I'm not giving specific examples. I gave the example when I talked about the cargo cult in Vanuatu. Hopefully that's how I should pronounce it. But what am I doing when I talk about this general term? Yeah, Caitlin, I'm setting up for a third paragraph. Okay? What do you think is going on once you read this? Now, I talked about how these people in the past on this remote island did these things that came to be, had this system of beliefs that led to cargo cults. And now I'm talking about how it's become a general idiom to describe something as a cargo cult if people are mimicking actions without doing the real thing. So something is changing in this paragraph, right? What do you think? What's going on? I'm setting up for the third paragraph. What do you expect to happen next, Caitlin? What do you expect once you read this? What do we expect? I went from history, and now I'm talking about how this is why the word has the meaning. Yeah, something similar to the tribes, but more modern. Example of how cargo cults are used today, or cargo cult thinking or behavior, right? This is what we would call the twist, okay? This is the twist where we go from the past, this thing in history, to, okay, now it's an idiom for people doing the real thing, and then finally to the third paragraph where, sure enough, we give an example of modern people, cargo cult scientists. All right? So what else is going on in that third paragraph? By non-natives, right, by the scientists. Exactly. Exactly. So what else is going on there? And once you've read it, what do you think about the whole thing? All right, what do you think about the whole thing? No one wants to answer. Okay. All right. There's this specific example, right? They talk about the cargo cult scientists, and then you get a very detailed example, okay? You don't have to spend your time obsessing about these details. All you need to note is, oh, now there's an example. Okay, so here's the modern example. All right? Okay, so everyone comfortable with the sketch, with what's going on in the passage? Anyone have a different take? Comfortable? Smile if you're comfortable so far. I want to go on to questions and question answering techniques. All right, because half the battle here is the comprehension, this whole thing of the structural comprehension, knowing what's going on. We're going to think about main idea questions, and you typically will get 1 or 2 per passage, okay? And there's some things that are very helpful, okay? A main idea has to apply to all parts of the passage. And this is very, very important. It should take the twist into account. This is a weird passage, right? At first we're talking about, people on remote islands in history, and then we're switching it to the present. And what's the link? Oh, that they're mimicking actions without doing the real things. So, the main idea should be taking that into account. Also, shouldn't be too narrow or too broad, okay? And they're often very boring. A main idea is not particularly, it's often stated in boring language. All right? What do I mean by not too narrow or not too broad? What do I mean by that? Okay. What would be too narrow here, given the 3 paragraphs that we read? What would be too narrow? What would be too narrow? These two, by the way, kind of overlap. Anything that doesn't cover all the real estate is by definition too narrow. Okay. Yeah, focusing just on the work on the villagers. Exactly, Catherine. And too broad would be something like talking about silly things that, silly ways of thinking that people have, or non-scientific ways of thinking in general or something like that. That would be way too broad. It needs to be just the right size. Anything that's covering the main idea has to just fit all the material in the passage, and most of them have a twist, so it also has to cover that twist. Okay? So, why don't we try a main idea question? Once you've thought about it, and we have our map of the passage, it should be relatively straightforward to do a main idea question. All right? But I will tell you that you're going to have to use process of elimination because a couple are quite tempting. All right, let's try this on the timer. We'll spend a minute on it, which is about the time that you'll have, given that you have to spend time reading. Try it out. Okay, guys, time to pull in answers. I know there are two answers that are really tempting. Pull in your answer. Pick one and guess, because we're going to talk about how to go through the process of elimination and how to get to the right answer. But please, everyone, pull in an answer. You should have been able to eliminate some by now. Okay, we talked about how. All right, I am going to, let's see. I'm going to ask, the primary purpose of the passage is to. Okay. All right. Catherine, I know you don't have a mic. All right. Did you use process of elimination in looking at these answer choices? I want to see if I can get someone to help me with the whole process of elimination thing. All right, knowing what we're looking for. Okay. Yeah, the little signs that we use for other verbal stuff. Exactly. Okay. Yeah, we know it has to cover all the real estate, not too narrow or not too broad. Take the twist into account. All right, and other things we've talked about. Okay. Things like anything that's too extreme is unlikely to be it because we would need such extreme evidence. So, let's see. Interestingly, we have three different answers chosen, C, A, and B. So we're going to start off with eliminating the two that nobody chose. Okay? What's wrong with D? What's wrong with D? Why isn't the primary purpose to argue that it is important for scientists to take into account the research of other scientists in their field? It's too specific. Exactly. Exactly. I might also say, this is bigger than the cargo cult thing. It's specific to the third paragraph. That's true. It doesn't cover everything. And it's too broad. We're only talking about a specific error. Okay, the specific error of mimicking actions without doing the real thing. Okay, so it's both too narrow and too broad. So it goes. What's wrong with E? Now the answer would never, never, never be E on an ETS test. Okay, and someone can tell me why. There's another reason. But what's wrong with E? Imply that cargo cult, okay, doesn't allow cargo cults to be applied as an idiom. Okay, imply that cargo cults members' mistaken logic could be remedied through the scientific method. Okay. Yeah, it doesn't really talk about the cargo cult idiom, but what is this thing with the scientific method? All right. Cargo cult members. Are the scientists cargo cult members? Are the scientists cargo cult members? No, they're not. Okay, so it doesn't really cover the scientists. they're supposedly using the scientific method, but Feynman is saying that it's cargo cult science. Anybody know who Richard Feynman was, by the way? Who's a very famous physicist. Wrote a really famous and funny book called Surely You're Joking, Dr. Feynman. Okay. Did all sorts of really interesting things. Sat on committees to improve textbooks in public schools, science textbooks, and discovered that many people reviewed textbooks that didn't exist. He tells great stories, just as an aside. All right, the guy who's quoted in the article. Now, let's go back and look at A. Offer a suggestion for improving the results of scientific experiments. Why could A not be the answer? Why would A not be the answer? Why would A not be the answer? It is specific to the results and methodology of science. Right. Absolutely. A is too narrow. And here, let me write this down. Too narrow. Scientists only. Okay. Too narrow. Let me write these down. Scientists only, but also too broad. Beyond. Okay. Cargo cult members, this is too narrow. No scientists. All right, so then you have to decide between B and C. Catherine. Okay. Why is it B and not C? Okay, why B? What is wrong with C? What is wrong with C? Yeah, C is too narrow. It's talking about the cargo cults only. Okay, and so although B is quite boring, suggests that two disparate groups of people share similar logical errors, B is what's left. B has to be correct. It encompasses both the scientists and the people with the cargo cults. And you would say, well, it also is fine for that middle paragraph because it talks about the meaning of cargo cult, the idiom of cargo cult in modern usage, what it means. Okay, so, it talks about this logical error. All right, so our correct answer has to be B. And we get to it by eliminating things that are either too narrow or too broad. Questions about this. What made this hard? How did people get stuck? Before I go on, what made this one rough? All right, anyone want to share thoughts on what made this one rough? It's really important when a problem was hard to go back and analyze it and to think about why, to think about what you could have done differently. This is how we get better. So I'm going to encourage everyone to participate in this. Don't be embarrassed. You're in class to learn to get better. Experts start as novices. Okay, so it's really important to do this kind of analysis. Okay. Caitlin, excellent point. I got confused and thought cargo cults included the tribes and the scientists. Right, now you see they're separate. Okay, so we have the cargo cults and the cargo cult science. The scientists weren't actually members of cargo cults. Their behavior was just had a similar logical flaw. All right, so Good, good, good. So what could you have done differently? Do you see anything that you might have done differently? It is a tricky passage, the subtle distinction between the cargo cults and cargo cult science. Was there a clue or anything in the passage that might have helped you catch yourself? Okay, because I made the same error that you made, by the way, the first time I did this passage. All right. Very important to look and to do some analysis and think about why and how could you prevent the error. All right, I see both Caitlin and Emma talking. Does someone want to grab the mic? It's absolutely fine. You can raise your hand if you want the mic, otherwise you can just keep typing. Okay. I see you typing, Emma. All right. I will tell you that when I went back and looked at it, I realized that I didn't pay enough attention to that second paragraph. That second paragraph is the twist. It's very, very important. It ties together what are otherwise two very different, disparate paragraphs. Okay, and it's the one that abstracts it out to get the general pattern, general principle. And that paragraph should have been a warning. I read this very specific example of cargo cults. You know, it looked like I was getting a history of, you know, Pacific Islanders or something. And then there was this is how this word has come into our language. That's the thing that should have caught me. Aha, the twist. All right. And if I'd logged that in my notes as the twist, then afterwards things might be quite different. All right, I'm on alert to be careful after the twist. And that I find can be very helpful. All right. Okay, so Emma is saying, I think just be aware of the first sentence in the last paragraph. Most times they tie the passage together. Also the change of direction in paragraph 3 to the rest. Okay, yeah, paragraph 3 is very different from paragraph 1. All right. Okay, so being aware of a big change in the writing, you have a big shift. So very similar to what I was saying. All right, good. Okay, and this is critical, by the way. If you want a really high score, you have to dissect your wrong answers. You have to sit and think, why, what did I do? Okay, you don't just do more problems. Let us look at something else. Okay, I just want to show you a summary here. All right. Okay, just a summary of these answers. And I did want to point out the thing I forgot to mention about E. It's insulting to the cargo cult members. And the GRE is always politically correct. So nobody was fooled by this. But if you see something that is insulting to a minority group or any other group that shouldn't be discriminated against, it's not the right answer. All right. C is a really common type of trap that we're going to talk about. It's something that is true, but it's not the main idea. It's too narrow, but it's also a true fact, and this is a common decoy. Okay. A very common decoy. And notice that some of the language is highlighted here. Okay. Offer a suggestion. Well, the passage doesn't really offer suggestions. Argue. Well, it's not really arguing. So there are multiple ways to attack this. I really like narrow and broad, but you can also look at these other things. Okay. What is it actually doing? It's pretty bland. Suggest is the right. Suggest or explain. Okay, are really the correct words. And C is incorrect because although this is true, it's not the main idea. It's too narrow. Okay, so this might be something that you would write out after you get a question wrong. You want to write something like this out and figure out and explain your whys. Okay, so now I'd like to move on to detail questions. Detail questions are nice because the answer is going to be written down for you in the passage. It says, don't think for yourself or add information. And that's really true. They trap you often by getting you to assume something that seems to follow logically. Be very, very careful. The key is to use what you've written down, use your passage map to get yourself to the right location. Okay? Then start reading, chunking along. All right? And eliminate wrong answers. Okay, so tips on wrong answers for specific questions. There's often only one word that makes them wrong. You have to pay super close attention to language. And the thing with extreme language comes up a lot. You will often see something that seems to be generally true, but it's just too extreme. Remember, they're very literal-minded people, the academics who write these. And so if something is extreme, you need extreme evidence to support it. Okay? And just like with the general questions, you still have these true fact decoy answers. Answers that are true but that don't answer the specific question. Another thing that comes up in these detail questions a lot is that if you see exact repeats of the language, be careful. It's not necessarily incorrect, but it's often a trap. They'll exactly repeat a part of the language, but say something different. Use it differently. Okay, the simplest one is just a reversal trap. All right, where if the passage says X is true, then you get an exact match to X, and it's X is not true. Okay, so be careful of these traps. We're going to do a detail question. Generally, detail questions take people a little longer because you're going to have to go back into the passage and reread a section, and that's fine. Okay, let's try this detail question out. We're going to take a minute and a half, and let's check it out. All right, everyone put down an answer. Time to guess if you don't know. We're going to go through how to do this one. Okay, so the passage suggests that residents of Tana concluded that they were the rightful owners of the cargo because. And again, nobody chose D or E. D or E have the same flaw. What's wrong with D and E, guys? What's wrong with D and E? I'm going to get someone to go through the more interesting options, but what's wrong with D and E? All right, looking at D, Allied forces had given them the cargo. Exactly, Caitlin has it. This is a true fact. And E is also a true fact. Okay, but they don't answer the question. So now I'm going to ask Emma to help us go through process of elimination with A, B, and C. Emma, is your mic working? Why don't you help us out here? Nope. Okay. So that's all right. Why don't you type? Okay. So what's wrong with B? What's wrong with B? They believed all possessions were created by deities. What's wrong with B? You can even just highlight the word. There's one word that makes B problematic. What is wrong with B? All. Yeah, all is very extreme. They do believe that you are told that they believe that the deities can create possessions, but all is such a strong word. All possessions? Okay, so this is really the extreme language. Okay, too extreme to say all. All right, and what's wrong with C? They believe they were owed a debt by their ancestors. Again, it's just one little section. here. One little section. What's wrong with C? Why don't you highlight it, Emma? What is wrong with C? Yeah, owed a debt. Where does it say they were owed a debt? Okay. They believe they were owed a debt by their ancestors. It doesn't actually say that. You know, it talks about how their ancestors gave them things, and their ancestors, you know, they thought that these were gifts from their ancestors, but where does it say that they were owed a debt? Thinking that something is a gift isn't quite the same as thinking that you're owed a debt. Okay? And so what you're left with is A, they found stories of the goods' actual origins to be incredible. Now, what sentence, what line in the passage supports that? What supports that? Okay. What line? Around where? Yeah. I would say it's 10 to 15, definitely. Okay. What it says, members of native societies having little knowledge of Western manufacturing found soldiers' explanation of the cargo's provenance unconvincing. Okay. What does provenance mean? That's a cool vocab word. What is provenance? Anybody know what's provenance? He found the story of the provenance unconvincing. Provenance is a word that you hear a lot if you watch something like Antiques Roadshow. And provenance is just where something comes from. Ian really likes this word because he's an archaeologist. He's very into provenance. All right? And he's smiling at us. Okay? So that would be a nice vocabulary word to add. Okay? Even if you didn't know that word, you might be able to say, oh, that means where it came from. All right? Questions about this one? Again, I'll show you my little grid. All owed a debt. We got everything. Very well done, Emma. Okay. Very, very well done. Okay, and what do we think went wrong? Anyone? Anyone else? What would have made it possible to get the right answer here? Anyone have a thought? All right. Catherine may be typing. Are you typing, Catherine? Okay. Accidentally ignoring the all. Yeah, absolutely. It's an extreme word, but it's so small. Okay. So most of them, I won't say all because that it's extreme, most of them have an extreme trap, and most of them have a true facts trap. These are very, very common. These are the most common types of traps. All right, so some further thoughts to follow up with. The GRE loves to paraphrase, okay? They will seldom reuse the exact same words on a hard question. The cargo's provenance, that's the same as where the cargo came from, the goods' actual origins. If you say something is unconvincing, that's the same as saying you found it incredible. Soldiers' explanations of matches stories of. You don't have to think or add information to the passage, but you may well have to paraphrase. If they use the exact wording, be careful. It's not always incorrect, but it's more likely than not a trap. The correct answer usually involves paraphrasing in these detailed questions. Okay? And I love what Caitlin is saying. You assume they owed a debt even though you didn't see it. That's adding stuff in. A very, very common GRE trap. They are trying to trick you into adding things in. And it's really important to stay only with exactly what is there. All right. Really good job. Now I have just one more question. I know we're at time, but I want you guys to try this one. This is an excellent question. All right? And take everything you've learned from these past two questions and pull it into this one. All right, awesome. Okay, everyone who answered correctly. The right answer here is C, yay. Okay, so quickly let's run through. Caitlin, do you have a mic? Do you have a mic? Is it working? You guessed on this. Okay, let's go through how we eliminate. What's wrong with A? Both use inappropriate equipment in trying to cause a phenomena. Why doesn't A work? What's the failing on A? What's the error? All right, I'm going to ask people to highlight. Scientists were using appropriate equipment. Exactly, Catherine. Exactly. All right. Causing a phenomena. They were not causing the phenomena. Or trying to cause. You could argue that they were trying to cause something. I would say that inappropriate equipment. Here, let me just show you. Okay. All right. You could also say that the scientists were not testing correctly because they had their mazes were not on sand, and you could say that was inappropriate equipment. Or you could say, no, the scientists weren't really using inappropriate equipment. They were just using their appropriate equipment inappropriately. All right? If I look at B, the problem with B, refuse to accept the principles of the scientific method. No, the scientists don't argue against the scientific method. Okay, and this is very, very strong, refuse to accept. I don't think you could say that about the scientists. D also is very extreme, no logical basis, and it's pejorative, right? Do I want to say that about the cargo cult members on Vanuatu, that there's no logical basis for their actions? That's very, very strong, and it appears to be discriminatory. It's definitely not politically correct, okay? Both would benefit from enhanced scientific education. All right, again, that is insulting. That would be rude to say either to the scientists or the cargo cult people, and the GRE just doesn't do that with answers. Also, the passages rarely give policy recommendations, would benefit. This is just not something that's typical in an answer, okay? So again, we end up with C. Very nice job. Now we have just a few minutes left, okay? And I'm really happy that everyone who answered got that. I just want to tell you, short passages are like long passages, except they're a lot easier. They're like an excerpt from a short passage. But they will also, you're still looking for a main idea, which could be a resolution or an answer, a twist, a change, reason or judgment call. Short passages also have main ideas. And typically, when there's a question about a short passage, it's more likely to be purpose or structure because it's a lot easier to locate specific details, so less likely to ask that kind of question. Okay? So the whole comprehending as you read becomes even more important with a short passage than a long passage. All right? Every sentence, you need to understand its role. What is it doing? Okay? So if you're going through, you're answering this question, which sentence describes the aspect of bloodletting later shown to conflict with certain scientific discoveries? All right. Okay, here it is. All right, you would consider all the sentences. Okay, so if you think about this, all right, this is another type of question that you'll see. Consider each of the choices separately and select all that apply. The highlighted sentence has which of the following functions in the passage? Why don't you guys mark up the screen? All right, the highlighted sentence has which of the following functions? Let me give you a moment, a little bit of time to read this. I know we're over time, but this is pretty helpful. Everybody seems to be a really fast reader, and the correct answers were highlighted. Okay, you will have to do some like this. I generally find these easier than the long passages because they're just less to keep track of. All right, this was well done. Any questions or comments on this one? Okay. Typically, you're going to have at least one of the really long passages. And these short passages work like little excerpts of them. They typically are easier. All right. No questions, no comments. All right, so next week we're going to look at inference questions. This is another type of question. It's a kind of a specific detail question, but they ask you to make a logical inference. And we'll talk more about that. It's a very narrow inference, contrary to the type of inference we typically make in real life. So please look at this week's RC handout and try the two inference questions before we look at the inference questions next week. That'll be really helpful. Okay, I think we are all done now with reading comp, guys. Good job. Really good job, particularly in thinking through why you made mistakes. That was excellent. Let me toss the mic back to Ian so he can wrap things up.
Thanks, guys. Thanks for sticking around a little bit extra today. Hopefully it was well worth it. We will take any questions that you guys might have, as always, after class. But in the meantime, I'm going to go ahead and turn off the recording, and for any